Alright, so in our last 3 videos, we've been discussing how to prove 2 different triangles congruent. We had angle, angle, side, angle, side, angle, side, 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 angle, side, and hypotenuse leg. But why did we discuss this? Okay, what we're going to do is we actually have to prove it. And if we prove 2 triangles are congruent, then we know that their remaining sides must also be congruent. That's where you get CPCTC. Corresponding parts of congruent triangles are congruent. So if I know 2 triangles are congruent, then their corresponding sides and corresponding angles have to be congruent. They have to be. Okay? Alright, so I want you to take a minute and watch this video. You can watch it after mine. But it's from Tyler Tarver, and he is discussing CPCTC. Now, he's absolutely hilarious. I will never pretend to be as funny as he is. Okay? But I do want you to watch and listen to him because he makes some really great points and all the while being interesting. Okay? Alright, so before we get into all the rest of this, we need to discuss some vocabulary terms. Remember that 2 figures are congruent if they have exactly the same size and shape. Remember that when we dilate things, we don't have the same size anymore. So those are not congruent. Now, corresponding angles are when we talk about 2 triangles being congruent. So let's say triangle ABC is congruent to triangle DEF. We can say that A and D are corresponding angles, and that B and E are corresponding angles, and C and F are corresponding angles. Corresponding sides, same thing. AB corresponds to DE, BC corresponds to EF, and AC corresponds to DF. Alright, so given this triangle and this information, we need to prove that the 2 triangles are congruent before we can say that XT is congruent to TZ. Because if we can prove these, we can do it by CPCTC once we prove the 2 triangles are congruent. Alright, so then what we're looking at here is we want to go ahead and put our information in. It says YT bisects XTZ. So XTZ is being bisected by YT. That means this angle and this angle are the same measure. It also says that YT is perpendicular to XZ. So YT and XZ, that means that these 2 angles are right angles. And we also know that this side, YT, is shared by both triangles. So let's go ahead and start with what we were given. We're given that YT bisects angle XTZ. And that YT is perpendicular to XZ. All of that is going to be given. Alright, now, because YT bisects XTZ, we know that angle XTY is congruent to angle ZTY. And that would be the definition of bisection. Then, number 3, we need to say that these 2 angles are congruent because they are right angles. So, knowing that they are perpendicular, we can say that angle XYT and angle ZYT are right angles. And that would be the definition of perpendicular lines. Then we can say that they are congruent because they are right angles. So the definition of right angles means that they have congruent measures. They are congruent because all right angles are congruent. Alright. We also wrote on our page that YT was congruent to YT. Okay, remember, anytime I'm congruent to myself, that is the reflexive property. And now we can prove these 2 triangles congruent. We can say that triangle XYT is congruent to triangle ZYT. Okay, remember, order is very important on this one. Now the reason why, now some of you will try to say HL. Remember that you have to have the hypotenuse congruent to the other. Notice we don't know anything about the hypotenuse here. However, this is angle, side, angle. And now that we know the two triangles are congruent, we can say that XT is congruent to TZ. The reason for that is once the triangles are congruent, their corresponding parts have to be congruent. So you're going to write CPCTC. Corresponding parts of congruent triangles are congruent. Alright, in this example, it is our job to find x and y. We are given that quadrilateral DEFG is congruent to KLMN. So DEFG is congruent to KLMN. Now, we first off see that MN is 5x plus 2, and it corresponds to FG. So we can take 5x plus 2 and set it equal to 12. Subtract 2 from both sides gives us 10. And divide both sides by 5, x equals 2. So we have found the value of x. Now, y is angle L. Angle L corresponds to angle E. So we take 5y plus 6 and set it equal to 110 degrees. Okay, by subtracting 6 from both sides, we get 5y equals 105. Then by dividing both sides by 5, we get that y is 21. Here we need to prove the two triangles congruent, if we can. And if we can, we need to state why. Well, first off, I can see that this angle and this angle here are congruent by vertical angles, correct? I also have that 81, angle D and angle H are both the same measure, so they are congruent. And I have these sides. So I can actually prove this in a couple of different ways. Notice I have 3 pairs of congruent sides. Because of that, I can prove it with side, side, side. Or I can even look at this and say, oh, I've got angle, side, angle. So there's angle, side, angle. Then, if you recall the third angles theorem, it says if 2 angles in one triangle are equal to 2 angles in the other, then the third has to be the same. Okay? So I can even prove it with side, angle, side. And angle, angle, side. The only one I can't prove it is HL. I don't know if any of these angles are right angles, and if I did, then I could say this would be hypotenuse leg, but I don't have enough information to determine that at this point. Alright, so we are given some information here that we need to plan. We're given that angle BCA is congruent to DCE. Notice how I'm putting the markings on my triangle. Alright, and then I've been given that angle B and angle D are both right angles. Whoops. And that line BC is congruent to line CD. So that's there and there. Whoops, excuse me. Don't know what happened there. Alright, so we've been given all of this information. Okay, so we need to write that down. We also know that angle B and angle D are congruent because that's the definition of right angles. So, whoops. Don't know what's happening here, guys. Sorry about that. So we can prove that these two triangles are congruent by angle, side, angle. Now, some people will try to say HL, but you don't know that line AC and line CE are the same. So we don't know if the hypotenuses are the same. So therefore, since the two triangles are congruent, we can say that BA is congruent to DE by corresponding parts of congruent triangles are congruent, or CPCTC. Alright, so that polishes off that proof. On this one, what I'd like to do is I'd like to actually do it in a flow proof. So what I'm going to do is I'm going to give you the boxes, and then after you see the boxes, try to fill them in to the best of your abilities and create your flow proof. Alright, so here are your boxes. Remember that the statements go inside the bubbles and the reasons go outside of them. Okay, so try your best. Alright, so you can see here that I've written all my given in the first box. In the second box, I have that CB is congruent to CD. The reason that CB is congruent to CD is because C is the midpoint, so we call it the definition of a midpoint. I also have that ACB and ECD are the same by the vertical angle theorem. Okay, so marking everything that you have, you can prove these two triangles congruent by side angle side. So triangle ABC is congruent to triangle EDC by the side angle side congruence postulate. And that means that AB must be congruent to ED because of corresponding parts of congruent triangles are congruent, or in this case, CPCTC. Alright, here we have two more triangles that we're going to prove. This is going to be our last example for today. We have that AB is congruent to DE, that's given. BC is congruent to EC, that's given. And that C is the midpoint of AD. So making a plan here, if C is the midpoint, I can say that AC is congruent to CD by the definition of a midpoint. Then that means the two triangles have to be congruent by side, side, side. So that means that by corresponding parts of congruent triangles, angle A must be congruent to angle D. Alright, so I am going to do a flow proof because we do two columns all the time, and I want you to try the same and double check with me in just a minute. Alright, now you could have done your flow in a couple different ways, but just making sure that the arrows follow in the correct order. I have stated my given information, but I actually broke up the given information into two boxes because if C is the midpoint of AD, then that implies that AC is congruent to CD by definition of a midpoint. Then, together with this piece of information and the other two pairs of course congruent sides, I can then prove the two triangles congruent, and then angle A is congruent to angle D by CPCTC. So it's very important to be able to look at a problem now and put your markings where the given information states, and then say, hey, by side 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 or angle angle side or whatever, I can prove these two triangles congruent. Because then once you prove the two triangles congruent, I can prove that any corresponding side is congruent to any other corresponding side, or corresponding angles are congruent. So this is very important. This has all been leading up to this point. Alright, well that's it for today, and I will see you guys later.